So this video is on writing equations for exponential functions, okay? Remember, an exponential function is a nonlinear function that increases or decreases rapidly, okay? And in this form, we know A is our initial amount or our y-intercept. B is our common ratio, okay? So with that, right, you could also look and use B to determine if it's going to be growth or decay, right? Meaning it's growth if it's increasing, and it's decay if it's decreasing. So right away, when I look at these tables here, right? So when I look at my Y values, I'm going from 4 to 12 to 36 to 108 to 24, 324, right? So I know right away this is going to be growth, and I have to check. 4 times 3 would give me 12. 12 times 3 would be 36, times 3 would be 108, times 3 would be 324. So I know because I'm multiplying by 3 each time, it's exponential growth. My initial value or y-intercept, I want to look for when x is equal to 0. That's this ordered pair here. So when x is 0, what's my y value? 12. And my growth factor or common ratio is going to be 3. So now I can write my function rule if I wanted to. The next one, if I look from 62,208 to 10,368, I went down. Since I went down, I know it's decay. But I have to determine if it's truly decay by making sure I have a common ratio or I'm multiplying or dividing by the same thing. So how do we do that? Well, what I like to do is to basically take, and I like to say new divided by old, or basically right over left. So if I take 10,368 divided by 62,208, right, I would get the decimal 0.166 repeating. If I were to do right over left again, 1728 over 10,368, I would get 0.166 repeating again. Now, if you do that in the calculator and you keep doing it, and you do 48 over 288, you should get 0.166 repeating. Now, 0.166 repeating is the same as 1/6. That means we're multiplying by 1/6 each time. That's decay because we're going down. Our y-intercept, I'm looking here. Our y-intercept is 0.1728, and the growth factor, or decay factor in this case, would be 1/6. Next one, from 5 to 40, multiply by 8. Here, multiply by 8, multiply by 8. Is that growth or decay? It is growth. My y-intercept, I look for x is 0. What's my y value? 5. And my growth factor, or common ratio in this case, is 8. All right. So number 4, from 15 to 24. Okay, if I take 24 and I divide it by 15, what decimal do I get? I get 1.6. If I were to take 33 and divide it by 24, I would get 1.375. Are we multiplying by the same amount here or dividing by the same amount here? No. Since these amounts are different, this is not geometric or exponential. Okay, now the next one, what I like to do is use the values that are easiest to determine. So if I take 12.6 and I divide it by 18, I would get 0.7. If I were to take 8.82 divided by 12.6, I would get 0.7. If I keep dividing here, I get 0.7. So that would be basically my decay factor, 0.7. My y-intercept, you should notice, is going to be 0.18. But because we're multiplying by 0.7 each time, and 0.7 is less than 1, we know it's going to be decay. You could also notice because it's going down. For number 6, I notice I'm going down, so it's either going to be decay or neither. And if I just take 2100 divided by 10,500, I get 0.2, but I have to make sure it's consistent. So 420 divided by 2100 is 0.2. 84 divided by 420 is going to give me 0.2. So yes, this would be exponential, right? Since we're going down, or 0.2 is less than 1, it's decay. My initial value here is going to be 0.84, and my growth factor would be 0.2. These are all very important to be able to determine what the function rule would be. So let's look at number 7. Here they actually want you to write the function rule. So what I first do is I find the y-intercept. That's the first thing I do. And remember, f of x basically equals the y-intercept times your common ratio to the x power. So I notice I'm going up here. From 3 to 12, I multiply by 4. 12 to 4, 48, multiply by 4. So right away I know my y-intercept is 3. Oh, so my a value is 3. So f of x equals 3 times my common ratio here, multiplying by 4 each time, and I'm going to raise it to the x power. And I'm able to do that because I started with the 0 value, and we said that this was growth. Now, to the next one. Here, I notice I'm going down, so I have to check for decay. So I'm basically, I sometimes like to look here, 96 divided by 24 is going to give me 4. And I know 24 divided by 4 would give me 6. So remember, if I'm dividing by 4, I have to know that's the same as multiplying by 1/4. So my a value, or y-intercept, I'm going to use is 6. This is my y-intercept. So f of x equals 6 times dividing by 4 is the same as multiplying by 1/4. So I'm going to use 1/4 to the x power. Since I was going down and it is exponential, I know it's decay. Next one, I notice I'm increasing, right? I know 15 times 3 will give me 45. I know 45 times 3 would give me 135, times 3 would give me 405, so on. So I know right away that this is growth. Now here's the thing. My y-intercept is nowhere to be found in here. But what I can do is work backwards to get it. So I know if the first term is 15, how do I find the 0 term? Well, moving forward, I multiply by 3. So moving backwards, I'm going to divide by 3. So 15 divided by 3 would give me 5. So I know my a value, or y-intercept, is 5. My common ratio is 3. So f of x equals 5 times 3 to the x. Remember, you could also, since you're not given the y-intercept, you could also use 15 if you start with this one. 15 times 3 to the x minus 1. So for number 10, right away here, from 1985, 1985. So I have to do the test here. 1906 over 1985. That would give me 0.96. 1832 divided by 1906 gives me 0.96. I should do one more to double check. So 1762 over 1832, 0.96. Right away, I know this is going to be decay. Now, I do know my initial value or y-intercept. So f of x equals 1985 times, what is my common ratio here? It is 0.96 to the x power. All right. Number 11. From 30 to 36, 36 divided by 30, what is that going to give me? 36 divided by 30 is going to give me 1.2, right? Then 43.2 divided by 36 is going to give me 1.2. Since I'm multiplying by a number greater than 1, I know it's growth. I do know my y-intercept. So my function rule would be 30 times, what's my common ratio? 1.2 to the x power. So for the next one, what I like to do with the graphs is I actually like to write the ordered pairs or write the table down. So if I look here, I know this starts at 0, 1, then it goes 1, 5, then it goes to 2, 25. So right away from this, I know my y-intercept is 0, 1. So I know f of x equals 1 times, what's my common ratio here? I know this is exponential growth just by looking at the graph. So 1 times 5 would give me 5. 5 times 5 would give me 25. So I know it'd be 1 times 5 to the x. Now, anytime you're given multiple choice with these, guys, do yourself a favor. Start with the y-intercept. I know the y-intercept of this graph is 0, 12. So right away, I know my function would start out with 12 times something. So what answers right away don't make sense? These don't make sense because the y-intercepts would be 20. So I can eliminate them right away. So now the next thing I have to determine, just by looking at the graph, I know it's exponential decay. And I'm going to look at my r values. I know if it's 8, I know it's going to be exponential growth, and it'd be like that. If it's 0.8, I know it's going to be decay like that. Which one do I have? This here is decay, so letter D. And I am done. Go ahead, do the homework, and let us know if you have questions.